Good morning, everyone. This is Derwood Shepard with the Roadway Design Office and Central Office Standard Plans Publication Engineer. We're going to go through the fiscal year 2018-19 Standard Plans Update Training. Just a general agenda for the training today. I'm going to walk through kind of a general overview of some higher level changes and website changes. I always like to mention the revision log. We get a tremendous amount of questions every year when content moves or changes, and the simplest place to find that information every year is within the revision history log that's always posted on the website. I'll show that in just a minute. Go through some of the deleted index that can be found on the history log, but I just want to kind of recap some of the indexes that have moved this year, and then we'll start going through some specific updates to specific standard plans. I'll cover some of the miscellaneous items. Richard Stepp will come in and discuss some minor changes to Guardrail, and then the changeover to single slope concrete barrier. Ed Cashman will speak to some of the temporary traffic control and temporary barrier indexes, along with signing, signal, and pavement marking indexes, and then Steve Nolan will come in and address the structures related indexes. So just kind of a general overview. At this point, I hope you're all aware of the change from design standards to standard plans. We're not going to cover that in detail in this update training because we've done that extensively over the last 6 months, starting with the Design Expo. There's a number of bulletins out there that are available that kind of went from the initial save the date type reminder to tell you this is coming, and with general information all the way through the crosswalk that we created, nomenclature to be used in both plans and DOT documents, how to handle the bridge standard plans, which are now be required to be attached in the structures component, and also how to handle the reference to the new standard plans on the lead cheat sheet or project. So there's webinars, training that we developed based off the Design Expo presentation that me and Gavin McDaniel did that is available in the training link on the Roadway Design Office. I'll show an easy link to get to it from the standard plan site again here in a second. And then one other thing that you'll note here is that the web link has changed for the standard plans. It used to be kind of housed under the roadway office, but since it applies more broadly, we've moved it underneath design. And unfortunately, moving forward, we're going to be handling the links to that website a little bit differently, so that if you bookmark the page, you'll always be going to the current version, whichever the latest one that's been published. So with the website, I kind of show the new front page here, but I'm going to bring up the website itself and just show you how a lot of that's working and how to maneuver the website. Previously, if you went to the main design standards website, you got a lot of information at one time, not only whatever the most recent published version was, but all the historical versions. There was the industry review links, the training links, the contacts, everything was shoved into one site. So with the implementation of the standard plans, we're also kind of introducing a new front page that allows for a little bit easier display of upfront information before you start actually trying to look at an individual set of indexes. So one thing that we are doing is the standard plans have been divided from the previous versions of the design standards. So if you're looking for, or you have a project that's working under one of the previous design standards, you'd actually click this link down here, and it would take you to the listing of all previous design standards. If you want to look at standard plans, there's a link here, and as we publish new versions of standard plans, this website will grow. We've also, because of, like I mentioned, the fact that now bridge component or bridge related standard plans will now be required to be attached to the plan set, we've kind of conveniently placed two different links here if you want to go directly to the bridge content versus what we're calling the road content. If you click on either one of these, it takes you to the same page. Just if you clicked on the bridge, it would automatically take you down to this lower portion of it. So it's all still contained on one site. We're just trying to be a little bit more helpful and some jump links there. So this is the primary website for viewing current standard plans that have just been published. I mentioned the revision log. That here is where you would access that. This shows for every index that was updated, deleted, any kind of content changed, there's a log here that has some indication of what changed on what sheet of that particular index. The other thing I want to mention is where the crosswalk link is. You can see that here. And this is the document we released with the bulletin previously to allow people to go ahead and start knowing what the new index numbers were for standard plans. And this is how this is being published to be included as part of the contract documents, because it's being published along with the rest of the indexes. So from there, just go back to the main page again real quick. We do have two different listings for developmental. There's ongoing projects using, developmental design standards. And as we convert those to, the new name and numbering convention, they'll get updated under this developmental standard plans link. Right now, if you were to go to developmental standard plans, you'll see the complete listing of all the developmentals that are available. But until they're requested, then we'll be updating the links that are active on this site and adding the projects that will be used under the standard plans implementation. Again, if you have any questions or concerns about the implementation of the standard plans, then I would defer you to the bulletins that we have released. It has all the detail, and then also the webinar that we put out there. So from here, another quick view of the revision log that I just showed you on the website. But what I really wanted to point out on this slide was the list of deleted indexes. Those appear first on the revision log because obviously if they got deleted, they won't be aligned with the new numbering system. But there are a number of indexes like the turn lanes, things like that, some of the interchange layouts that were indexes 301, 526, 527, and the intersection site distance index 546 that have all been absorbed into the FDM in its new format. One thing I do want to mention real quick, because we've had a number of questions on this about how you implement the standard plans but not the FDM, and I would just point out to people that although the names change from design standards to standard plans and the FDM changed from PPM to FDM, this is no different type of implementation year to year than it has been in previous years. If there's, the standards are implemented and are effective based on project lettings, and the design document, whether it was the PPM or the FDM, will be implemented based on when the project begins design. So if there's certain items within the standards or a spec for that matter that's applicable to your job based on its letting, that you would be responsible for making sure that those particular items are handled in the plans. But that doesn't mean that the entire FDM or in previous years a new version of the PPM is completely applicable to your job. So it would just be relative to any items that actually change within the standards or the specs. Okay, so now I'm going to go through real quickly some of the miscellaneous indexes that we did updates to before some of the other folks come in and do a little bit more thorough update on specific indexes. Starting out, we'll look at indexes 00515 and 00516, which dealt with turnouts and driveways, both for new construction and resurfacing projects. I'm going to start with the old 516 to start with, mainly because the change that happens to 515 is because of what happened on 516. And essentially, you know, there's a potential that 5 feet may not be the widest paved shoulder anymore in some of these areas with buffered bike lanes and a lot of other accommodations. There's a potential that it could be up to a 7-foot paved shoulder where we're doing some of these turnouts. So really what we did was just go through and remove the specific designations to the 5 foot that was required previously, because you really want to match that turnout pavement to whatever the paved shoulder width is. So we basically just took off the references, the 5 foot shoulder, and went with the original intent, which is match the existing paved shoulder for widths greater than or equal to 4 feet. For all other shoulder conditions, it must be constructed at least 5 feet. So for index 515, basically, there was references there to the other index, and we just got rid of the 5 foot call outs within the index. So nothing major there. For index 125.001, which is the utility adjustments through existing pavement, this is old index 307. And on sheet 202, we made a couple of additional adjustments or updates to the notes relative to adjustment of manholes. And essentially, we want to make sure that any adjustments are made prior to placing any friction course, and that any joints are located outside of the wheel path. So we updated the notes at the bottom of that page to relate that information as it wasn't previously handled either in the index or the specification adequately. So from here, we're going to talk about index 520.020, which is traffic separators. Again, this was old index 302. The primary reason for the change here is that when we removed the turn lanes index, which was index 301 previously, it had some details on there that showed how your standard curve would match up to a traffic separator. Not sure why it was located on that index to begin with, but since that design guidance that was on that turn lanes index was getting moved into the FDM, we took those details and moved them to 302. One thing we also did that I want to point out is that there was some information here about some pay item notes, and those notes will now have been deleted and will be moved into the specification going forward. So here, what just popped up on the screen was the details that got added in that show how the standard curve is supposed to match up to the traffic separator. So nothing major in that index, just kind of moving a little bit of stuff around and deleting some information that's covered in the specification related to pay items. Index 522.001 is concrete sidewalks. This was previously index 310, and we made a change last year to start requiring some areas other than the turnouts to require 6-inch concrete, and that was within the radial return at intersections, because we were still seeing a lot of damage to curb ramps and sidewalk in those areas when larger trucks would override the curb. So we made that change last year to make those areas 6-inch, but we were still getting some questions because the way it was shown on this index, we only showed one curb ramp type, and so some people were mistaking that to think that all curb ramps now had to be 6-inch. So we made some additional additions to the notes, and then also the plan view layouts, exhibits, and examples. And so I'll show those just a sec. One other thing I want to mention is the clarification for omitting joints within curb ramps. We deleted these call outs, and it'll be addressed as I show next on the curb ramps index, but I just wanted to point out that this got deleted here. Initially, the point of these notes about omitting joints was to to keep joints from being placed within the ramp itself. But over time, that note got kind of translated to you couldn't construct a curb ramp using joints at all. And so we are clarifying that, and I'll show that in just a minute. But further on this index, again, we adjusted the notes to better explain where the 6-inch concrete is to be located. And we also made a slight adjustment to there on the bottom where we called out the 2% and 5% cross slopes. Before there was an equal sign in there, and it kind of suggested that it was a definitive slope that those were to be constructed at, but really those are maximum slopes for those types of conditions, and so we adjusted that note as well. And finally, the detail on the bottom, we added in an additional curb ramp detail and showed that at the 4-inch thickness so that people weren't using this example to insinuate that all curb ramps had to be 6-inch. But then we also decided instead of showing a full return sidewalk and curb ramp configuration, we'd show a different type of curb ramp here, just again, because we're showing examples. We don't want to show it as though there was only one option that the 6-inch applied to. For index 522002, which is the detectable warnings and sidewalk curb ramps index, this was previously index 304, and again, we wanted to make sure that there was some little bit better notes on here handling the change between 4-inch and 6-inch and reference to the new index 522001. But then we also added in some additional call outs here pointing to some of these slope breaks that address the joint issue, and that these locations within the curb ramp joints would actually be permitted. It's just along the ramp itself that we don't permit joints. So we clarified those two issues on this index going forward. From here, I'm just going to really quickly cover some changes to the ITF indexes. Previously there was a number of 18,000 series design standards that covered ITF standards, and we basically either deleted or consolidated that entire list down to the 3 primary items that those covered, which are concrete CCTV poles, steel CCTV poles, and the dynamic message signs. And so, again, there's no major content changes to those 3 indexes, except that for the overall listing, we consolidated any of the relevant information as it pertained to the CCTV site layout, grounding, cabinet location. All of that information is just now consolidated into those 3 indexes, as you would see them for other types of signals and stuff like that, indexes that we have. So for what was 18100, the CCTV pole placement, this content is actually controlled by either PPM Chapter 4 or what is now FDM Chapter 215 with all the lateral offset and clear zone requirements. So, the contractor will be placing the equipment as it's shown in the plans. He doesn't need a standard to do that. The typical CCTV site layout, again, nothing could be considered project specific there. It's all general information about how a site might look, but those details and general layouts can be shown in the specific poles or signs themselves. The grounding and lighting protection was consolidated, again, with the CCTV poles and dynamic message sign indexes. Same with the cabinet layouts. The CCTV block diagrams were basically obsolete. Those types of drawings that shows how those cabinets are to be laid out are project specific, and those details are sold in the plan. So that index was deleted. The ground mounting and pole mounting details, again, were just consolidated into the primary indexes above, which would, again, be the CCTV poles or dynamic message sign. Just a couple other things I just wanted to point out about stuff that was removed was within the dynamic message sign indexes. There were some additional cabinet wiring diagrams and additional layout information that again would be project specific. So these details are obsolete and were deleted from the dynamic message sign indexes going forward. So at this time, we're going to move along to Richard Stepp's presentation with some updates to Guardrail and the single slope. So I'll invite him to come in and start his presentation.
So hi, my name is Richard Stepp with the Roadway Design Office in Tallahassee, the central office. I'm a standard plans engineer. Over the past year, I've worked predominantly on revising and redeveloping the standards that I have listed here in front of you. And so today I plan to just walk through some of these standards and give an overview, call out on some of the sheets, some of the changes we made that might be of interest to designers. And so we have made changes to the guardrail, as Erwin pointed out, concrete barrier, pier protection barrier, some inlets that work along with our barriers, and then standard aluminum lighting, so as it relates to the barriers. And you'll notice the theme here, it's the single slope barrier. And so basically we're going to just be showing you all the effects that the single slope barrier has on all these different types of indexes. So starting off with the guardrail, just some quick miscellaneous updates that might be of interest to the designers. We'll just quickly go through those. And so we did make some changes for single slope barriers. Basically, the barrier itself, as it connects to guardrail and the offset blocks have changed. We've got some miscellaneous updates for constructability and clarity. And today's presentation covers, designers' items of interest for designers, and that's true of all the future indexes we're going to talk about. We have made lots of little miscellaneous changes and improvements for the clarity of what contractors are doing in the field, but today we're just going to focus on the things for designers. And so for the complete red lines of all changes, if you're interested in that, you can see the Office of Design Industry Review website at this link. And okay, just going through a few things we've changed with the guardrail concerning the designers. We had received some input on this. So in the recently released standard, we went ahead and called out the maximum slope on shoulders for proper guardrail function. And so we had heard some feedback that, well, now maybe contractors might only look at the 1 to 10 max and then not realize that they need to be looking to the plans. And also designers might see this and think that, okay, they only need to meet 1 to 10 max. They don't need to look at the FDM. And so while it didn't really cause any conflicts, we just wanted users to realize that this was not the only criteria. So we went ahead and removed that as it's called out on the shoulder pavement. Now we did leave the 1 to 10 max in a few locations, just a generic cross section, and then behind the curb, because still we want to drive the point home that 1 to 10 max is the maximum slope for guardrail function. And then in order to leave that in there, we went ahead and add a little note that just explains the 1 to 10 max is for proper guardrail function only. And if you want, to see the project specific cross slope, you need to be looking at the plans, and then obviously the FDM governs the plans. And so now we're just showing some examples of single slope barrier as it shows up in the guardrail standard. This had been modified in multiple sheets, so we're just going to show you one of them. And so here you can see now we have this new little taper down at the very end of the concrete barrier, because now the new barrier is 38 inches high, but we still need to end it at 32 inches high to prevent kind of a snagging hazard of errant vehicles could hit the guardrail and slide along. We don't want them to snag on the concrete, so now it's got a little taper down. That shows up in the section views as well. And we have also revised some of the offset blocks. We had to finagle these a little bit to make it work properly, but we were still able to just keep it so the contractors have to make one cut, but the offset blocks got a lot thinner because the barrier sections are thicker up high. And then from the design point of view, we were able to make this so that the guardrail width at the connection point doesn't have to change at all. It's the same as it has been in the past, so nothing's changed as far as that's concerned. And then the last point we're going to mention for guardrail is we've added the ability to terminate the pipe rail on a steel post. And so in the past, I think the assumption was that, you know, basically the purpose of the pipe rail is to be providing some degree of protection for pedestrians and bicyclists when a sidewalk or shared use path is within 4 feet of the back of a steel post, because, you know, there could be some sharp edges on the steel flanges. And so the idea is that, okay, well, in an urban area, typically you would end with a timber post approach terminal, and then you don't need the steel pipe rail, so you go ahead and terminate on a timber post. Now, there could be a case where simply the sidewalk comes near the guardrail post and then veers away, and then you don't need the pipe rail anymore. So now we've added this new option so you can terminate on a steel post and not have to worry about putting in a timber post among around a steel post, because we had gotten some questions about designers on that. So now you have both options. You can end it either way. Okay, so now we'll move on to speaking about the concrete barrier. This is the most extensive project I'll talk about. Moving through these indexes, it's the lengthiest, but I'll explain why. So basically all the barriers were upgraded to the single slope sections to accommodate larger vehicles for MASH compliance. And the standard plan sheets were completely redrawn, rewritten, reorganized just to improve the clarity of notes for details for designers and contractors to more easily understand what's going on in the indexes. We also introduced some new standard plans instructions, or SPIs, just to improve the clarity of the process for designers. It's kind of an educational material. It's a good starting point if you've never designed concrete barrier. We also have a new length of need design tool to assist designers with learning the AASHTO roadside design guide barrier length process. It's very similar to the one used for guardrail. And so we'll take a look at those. And then, you know, again, today's presentation just covers the select items of interest for designers. So looking at sheet 1 now, we've got a new table of contents over here on the left, so you can more quickly get the information you're looking for. If you notice, we've organized these. We now make it clear there's just 3 distinct barrier types. So we have the median barrier, shoulder barrier, curb and gutter barrier, and we'll define those as we move into those sheets as we step through this. We've rewritten the notes throughout with concise active voice with headings. So again, rather than just a solid sheet of text, you know, when you're trying to find specific information, you can now just, you know, look through and look for the note heading that interests you that you need to know about. So we've got a new welded wire reinforcing option for contractors. So that's just a note letting the contractor know that they can substitute a welded wire reinforcing for all of the steel rebar mild steel reinforcing that's shown. And then an item of interest for designers is the minimum barrier length is 40 feet. That's just required for a dead load to resist overturning upon an impact. And then we've also have, you know, miscellaneous items for contractors here. So, okay, moving on to sheet 2 now. This is the first sheet and, you know, like the median barrier grouping. So the sheets that immediately follow this are all median barriers and variations of median barriers. And so I like to start off each section with just a simple plan, elevation, and section to show the most basic type of median barrier, just, you know, so contractors can get their bearings. And then we show, you know, connection to guardrail, connection to traffic railing, wherever it's applicable, just as examples for the contractor. And then one thing that's new and interesting is that for this particular connection median barrier, you're going to be connecting to double face guardrail, and that requires some length where the guardrail panels are at the same elevation. And for that reason, we've come up with a segment that needs to be 16 feet long, where you have symmetrical median barrier in order to accommodate that connection to guardrail. So for the last 16 feet, you have to use your basic type of median barrier, which is 38-inch height, shown here. And then after that, you can transition into the sign support type of barrier or grade separated barrier, or basically all the options we're going to show you on the upcoming sheets. And speaking of the options on the upcoming sheets, we now have 4 pay items for median barrier, which the first one is just 38-inch height symmetrical, which is shown here. That's the basic. And then the next type is short grade separated, which is on upcoming slides. And then the tall grade separated, which gets even more complex, add the footing to it. And then the last one is just variable section for sign and pier shielding. And we want to more accurately capture the costs on these per linear foot. So previously, we just had one pay item for all these different types of barriers, and we weren't really getting accurate costs per project. So this will help with that. On the next sheet, we're showing a new reinforcing we've added to the medium barrier. Essentially, this provides some nice continuity for intact of larger vehicles for MASH. Provides support. This is the minimum possible reinforcing needed in order to slip form properly, and so it prevents the concrete from slumping. These are taller, narrower barriers, and so now we have reinforcing in these as well. And we also show the details on this sheet for narrowing down the section for connection to guardrail. And you can see we have our 3-inch cutback to avoid that wheel snagging, and then the height also reduces to get down to guardrail height so that vehicles won't get snagged over the top. So looking at sheet 4, this is for our sloped end treatment. Now this is basically used, obviously in the medians for median barrier on the trailing ends and then outside the clear zone. So anytime you have approaching traffic that's within the clear zone, you're going to want to shield the blunt end with either a guardrail approach terminal or the crash cushion. But then this is just for the trailing end and then outside the clear zone. And so the usage is explained clearly in the new SPI. We have a nice table to explain end treatments for approach and trailing ends of all of our barrier types. But this is what that's used for. Okay, now this is, from a design standpoint, our grade separated barriers is very similar to the previous standard. And that's a note I want to make too. When I say all new, I mean it's completely redrawn. All the notes are rewritten for clarity. Obviously moved the single slope barrier. But most of the concepts are carried forward from the previous standards. So that's why I'm not going into detail on every concept. So it is similar to the previous standard in terms of how it works with grade separation. Minor changes in the heights that apply. We also, it's important to note, we have a little bit larger spread footings for MASH, which are seen in this table. And so, if you're used to the footings being a certain width, just know that they've gotten a little larger. So you can account for that when you're planning which footing you want to choose and where your utilities happen to be. And then moving into sheet 6, which is for supporting signs. This is the option with the minimum width barrier section. And we have an upcoming option that's, can accommodate a larger if you have more lateral clearance. But anyway, so we've clarified where the project-specific reinforcing goes up here as needed to basically support the overhead sign support and then connect that continuously to the foundation. And this is all a project-specific design that'll need to typically be made by a structural engineer and placed in the plans. And the notes here make it a lot more clear of what needs to occur in terms of what needs to go into the plans in terms of project-specific reinforcing. The one other thing I wanted to mention is that the pedestal width and then the overall length of transitioning to this width is governed, obviously, by the project-specific width of the sign support. Now, the maximum we've stated that this pedestal can be is 2 feet wide. I'm sorry, actually, that's the minimum is 2 feet wide. And that corresponds to the width of the barrier. So if the pedestal width is 2 feet wide, then there's no taper, which we say is permitted in the note. And then this just becomes the linear section that we had a whole sheet dedicated to this in the previous standard, but it's really the identical design. It's just that the pedestal width is only 2 feet wide to match the barrier. And so there's no taper and everything else is the same. So there's no reason to have a whole new index sheet just to explain that. So we placed that in the note, and that's acceptable to have the pedestal width be 2 feet wide. This is basically the same thing, just asymmetrical. So now you got a shoulder reduction on one side. And then, as I was mentioning before, the previous sheet I showed you was for the least amount of lateral space. the least amount of width. If you do happen to have some lateral space available on your project to fit this, some designers may prefer to use this option where you have an overhead sign support that you're shielding, but it's just independent of the barrier. You don't put the reinforcing through the barrier, and the barrier just basically goes around it. And so some designers might prefer that. And then also, this index sheet can apply if you happen to have an existing sign support and you just need to have some barriers that will go around it. And now we're getting into shielding of the pier. And I just want to point out that this, as opposed to pier protection barrier, which is the next index we'll talk about, this is shielding the pier, but it's only really for the crashworthiness benefit of the vehicle. So it's basically, we're talking about the vehicle safety. And then the assumption is that the pier is designed to withstand the impact of larger trucks. So if that's the case, the pier, you're not really trying to protect the pier itself, then you can go ahead and use this index sheet. And now when the pier is not designed to withstand the impacts, you want to use pier protection barrier, which I'll show you in the next index, 521002. And now I realize I just want to throw this concept out there. You know, people may want to give it some more thought, especially if you're designing a new project. We have guidance on this that begins in the standard plans instructions, and then the FDOT design manual as well explains that process a lot further, deciding whether or not you need pier protection barrier. And so in the next sheet, we just have some cross sections on the geometry you'll need to fit in your plans that go along with the previous sheet. We have all the cross sections cut, and then they show up here on the next sheet. Okay, so now this is something that truly is all new because we're transitioning between the existing old F shape and the new single slope barrier. Or you can transition to a single slope traffic railing. So really this handles any combination of going back and forth between single slope and F shape. And we just generically say F shape section over here on the right for that reason. So for example, you can have an existing bridge that's kind of an older bridge, has an F-shaped railing on it. For whatever reason, you're putting in a new roadway project and you want to use the shiny new single slope. And so over here on the left, you're using option A, which is the 38-inch high medium barrier. And basically you're just going along, and then you have your 10-foot transition. You have a continuous concrete between the new the new single slope and then the transition segment that goes to F shape, and then you would dial into the existing if that were a traffic railing. Now, also on the right side, you can say that, well, out there in the field, you have miles and miles of F-shaped barrier, but you want to install a bridge, and you know design life on a bridge is pretty long, so you want to put the nice new single slope in there. So in that case, you use option B over here on the left side for the traffic railing on a bridge. And then over here on the right would be the existing barrier that's out there, just the roadside item. And so you have your 10-foot transition, and then before you connect to the new bridge, we want there to be a minimum 2.5 feet. This actually gives a little leeway for the contractor that's outside of this 10-foot, because this will probably be a pre-made mold. And so then they have 2'6" minimum to make that connection to the bridge, because you're basically going to be between two solid objects, and the odds of getting the length exactly right are pretty low. So it just allows some flexibility there. And then also 12'6" is the min, just for dead load considerations. So moving on to sheet 12, we're now kicking off the shoulder barrier kind of grouping of the index sheets. And again, we start each grouping with just the basic elevation plan, section view, the contractors get their bearings, and then how to connect to guardrail. In this case, it's more simple, just for a single face shoulder barrier, and then how to connect to traffic railings and the like. Now, shoulder barrier is typically used on outside shoulders, basically where median barrier and curb and glitter barrier is not used. You use this on the outside shoulders. Generally, you know, if you had lateral clearance available for deflection of guardrail, that might be your first option. But if you were shielding a lot of things on the roadside that were very close to the barrier and you needed something very rigid, then you could elect to use the shoulder barrier. So now this gives you a preview of what the upcoming sheets are. So you have 3 pay items for shoulder barrier. It's pretty similar to the past. So we have the 38-inch and 44-inch height. The BOE, that's explained pretty clearly that those are the same thing. And that's just the basic shoulder barrier, as it looks right here, this section. We allow it to move up and down to reduce the Zoe requirement without changing pay items. So that's why there's 2 heights permitted. We have a retaining section we'll see on upcoming slides. We have a trench footing section on upcoming slides. And so go ahead and move into those. Quickly before that, we'll just show you, we have some reinforcing details. Again, we have the reinforcing showing the transition for guardrail where the section actually narrows. It also gets shorter to prevent snagging. And in the previous standard, I don't think we really had the details to show the connection for guardrail in this case, so now we've provided those. And then here are those alternative sections. You can select these as a designer as required. The retaining section here, one thing to note is that the heel has been extended by a foot to help support this soil. And so that's new in the new standard, so take note of that. And then now we have a new trench footing option, which could be more convenient for contractors. It's a little more simple than the spread footing design. You know, if you don't have any issues with depth of utilities or anything like that, you can consider adding that in. And then a couple more sections to accommodate basically reducing the setback requirement or zone of intrusion. We're talking about shielding piers, and those work on the next sheet. And then, again, as I mentioned before, this 44-inch height section, well, just raising it up a little bit, can still use the same pay item as, you know, the so-called standard 38-inch height. And so that's clearly explained in the BOE. Okay, so again, I'm going to go just quickly at a little spiel about the pier protection. And this is only really for the benefit of the vehicles. We're assuming that that pier is designed to withstand impacts per the, you know, the SPI, FDM, and then eventually LRFD requirement. That's all explained clearly in these documents. And so that is the limitation on this, is it's assuming that the pier is designed to withstand the impact itself, and we're just providing shielding for the benefit of the vehicle. This particular sheet is designed for low speed as opposed to the next sheet. And so it's less than or equal to 45 miles per hour. And what happens is the setback requirement for a zone of intrusion, if a vehicle were to hit this, basically drops to 0 when the design speed's low. And so the height of the barrier is not a concern in terms of zone of intrusion. And so we went ahead and had an option where we keep the barrier height the standard 38 inches. Just from a construction standpoint, it's just simpler and less expensive, so it's more efficient to have this option. And then we also have 2 options. So the first thing you would go for is to keep the full section width when shielding this pier, just out of ease of constructability for contractors. If you absolutely had to, because you're very pressed on space, you can go with the section that has a 3-inch reduction, where the barrier essentially wraps around the pier. And so on the following sheet, it's the same basic concept, except for this one is used for all design speeds. And because of that, in order to reduce the setback requirement, we've raised up the barrier, basically to reduce that setback requirement of the FDM, reduce the zone of intrusion. And so for all design speeds, you got to raise the barrier up a little bit higher. And then again, we got our transition to F shapes, back and forth between single slope shape and F shape. It's the same concept from sheet 11, only for shoulder barriers. And so we don't need to give this too much explanation. Same concept we got to cover for shoulder barriers. And then the final barrier type is the curb and gutter. It's basically the third category in here. This was simplified from the previous design a little bit. It's typically used in urban areas for designs to be less than or equal to 45 miles per hour. That's basically the same restriction on the type F barrier, or the type F curb, I should say. And it aligns with the type F curb pretty nicely for water conveyance. That 1'4" is basically the exact width of the front of the type F curb. And so those align, and it's kind of like your urban option. It has its own curb and gutter pay item, and then new guardrail connection details. And then, so the one point to emphasize moving forward is that the guardrail approach terminal is basically now becoming our primary first choice option for protecting the blunt end of this barrier in an urban area. So you're going to want to try to use an approach terminal And then that's opposed to in the previous standard, the only option we had was a sloped end treatment. And really, we just only want to use that where we have no better options, and that will be become like the last resort. And we have some restrictions on that. I'll show you in upcoming slides. The reinforcing details, you know, for the general run of Guardrail here, or, sorry, for the general run of a barrier are shown here, and then also the reduction in section width as it connects to Guardrail. So we have that all handled. And then, as I talked about, this is carried forward from the previous standard. The sloped end treatment only, like I said, this is considered the secondary option. It does have some restrictions on use. So this can only be used with design speed of less than or equal to 35 miles per hour. It requires DDE approval, and these requirements are seen in FDM 215, and the SPI will also refer you to the proper location in the FDM. And that's what I said. So the requirements are explained in the standard plans instructions. Got some reinforcing details for contractors, and then that wraps up looking at the index sheets themselves. Now, one thing I did want to show you really quickly is the new standard plans instructions. And I do consider this kind of like an educational document. If you're a new designer, this is the first place you would look to understand how things work. So the idea is that, go ahead and open this, see if it opens. You know, this we would hope would be written more clearly than I can explain it in this brief instruction that I'm giving today. But I just wanted to give you the overview so you have a feel for it. So the next time you open it up, you'll already have your bearings. So we give a brief explanation on the concrete barrier types, median, shoulder, curb and gutter, the design speeds that apply, what they're typically used for. We then go into shielding hazards and what our basic method is for determining the length of need. That will refer you to the FDOT design tool, which I'll show you next. We've got the different end treatments, explains on approach and trailing ends, what you would do for all the barrier types. And then how to, you know, connect to different types of barriers, and then just general plan content requirements. So I just wanted to give you a brief overview of what's in there because that's all new. Okay, and moving along, as I mentioned, the design tool for length of need. It's an Excel spreadsheet. I'll just quickly open that so you get a feel for it. The one thing I want to point out is this is very similar to the length of need design program for Guardrail. We have a training on that. It's a 17 training on our website. If you look at module 4, that explains the length of need calculations using the Excel sheet. So this is very similar. I just want to give you a quick look. So, you know, vehicle down here going from right to left, you're shielding this hazard. It just explains how to place the barrier and how long it's needed. The design input should be defined pretty clearly. And mostly this can be seen as kind of a learning tool just to understand AASHTO roadside design guide, because that's the basic process that we're using. We then consider two-lane, two-way. If you're in the clear zone from this lane of traffic over here on the left, going from left to right, you go ahead and design for the opposite side. So just wanted to show you that real fast. Okay, now we're moving into pier protection barrier. This is significantly shorter than the concrete barrier, so we should get through it a little more quickly. And I call this an extensive redevelopment because we did redraw and rewrite all the notes, but some things like the crash wall and the footings were in pretty good shape in the previous standard, so we were able to just copy them forward almost identically. So here we've revised sheet 1 for the general notes. We got a new table of contents so you can quickly find what you're looking for. Revised some notes for clarity, added note headings so you can quickly find your information. And the example layouts, these are, you know, helpful for designers and contractors alike, just to understand what to do in various situations when you're placing this type of barrier in the footings around the piers that you're trying to protect. And we also now show in this example the optional crash wall, and then a connection to guardrail or concrete barrier connection. And then one interesting thing I want to point out is that if you're connecting to concrete barrier, here we're showing guardrail, but you can also connect to concrete barrier for the previous standard, which is the smaller barrier than pier protection barrier. Then the crash wall would start at the end of the pier protection barrier, 0 offset. If you're connecting to guardrail, you're going to need to set that crash wall 3 feet back, as is shown, in order for the through bolts to work properly. So you need to provide space for that. So that's a difference in geometry you need to be aware of. We've got new plan and elevation sheet showing all the different combinations of height and what you're connecting to. And so essentially, you need a 56-inch height barrier. If the pier you're shielding is within 10 feet of the back of the barrier, you need a 44-inch height barrier, a little bit shorter up here, if your pier is more than 10 feet behind the barrier. And that's, I think, an LRFD standard. The guidance is provided in the SPI so that you would know that. And then down here, we show the difference in connecting to concrete versus guardrail. You can see the 3-foot setback for the crash wall. And then here we've got some reinforcing details. This is for connecting to the 38-inch height barrier at the end, so we don't need to come down quite as far as for guardrail. And so all the reinforcing details are handled. We've then got our connection. Now we're coming all the way down to 32-inch height. This very last little section here to connect to guardrail to prevent all the snagging hazards with the concrete if a vehicle were to hit the guardrail. And here we have differing footing options. Basically, it's the same type of dimensions for the previous standard. The requirements for the impact loads didn't really change. And so these were nice looking details. We were able to carry them forward. And then finally, the crash wall. This again has the same basic geometry as the previous standard. And then the one thing I'll point out is, just we added a little point here, station and offset for crash wall. The roadway designer put that in their plan. The point, it then defines all the rest of the geometry per the standard. So that, that point's important. That's also would be the length of need point as well in terms of the station. And we've got some reinforcing details for contractors, and that wraps up the index sheet portion. So again, we've heavily revised what used to be the instruction for design standard is now the standard plans instructions. We just gave it the kind of the organizational structure of the guardrail and the concrete barrier just to make it easy to find your way around and find the information that you're looking for. And anyway, but I won't open that right now just in the interest of time. But again, we look at kind of the SPIs as kind of like the educational material. It should be explained pretty clearly and just to help you learn about the design of pier protection barrier. And then one thing I will open, this is all new again, is the length of need design tool for designing pier protection barrier. So I'm going to go ahead and show you a couple plan layouts on what you'd be designing. So again, this would be for the simple pier protection barrier, and you can see where your length of need point is to shield a pier for vehicles that are moving left to right. We then have the opposite direction for 2-lane, 2-way. If this pier happens to be within 30 feet, then you need to design for the opposite direction. And then I wanted to show you the crash wall. The purpose of the crash wall is to reduce that overall length of the system. It reduces considerably, as you can see, from this length to this length, because you're gaining a lot of lateral offset, which reduces your length of need. And then the one other thing I want to mention is that if you are using a crash wall, the assumption is that you're going to be placing guardrail in front of it, and you typically would have a connection to guardrail. So for the benefit of general vehicles, you need to shield that crash wall from, for the, like I said, for the benefit of the vehicles. And so the guardrail would need to extend at least to this point. And so that's another thing I want to point out. The crash wall is considered a hazard to the vehicles, though it protects the pier itself. Okay, so moving on to our inlet types as they work with barriers. These should all go much quicker. They're just 1 or 2 sheets per index. So in this case, we have our typical revisions for single slope, as you can see. So we've, kind of cleaned up a lot of these details just to make them a little more clear and easy to follow. Switch everything to single slope, switch the inlet detail. We've removed the throat indentation. You can see on the isometric, it used to be up here, typically upstream when you have water flowing towards it. Speaking with Carl Spirio, the state drainage engineer, We've recognized that the benefit from that wasn't quite worth the time it took to construct these things. We found that a lot of cases, contractors were just kind of chiseling out like a throat indentation here, and it wasn't really performing as we had intended. We noticed a lot of cases it was collecting debris and trash and things. And so for the sake of simplicity, we just went ahead and removed those throats. And then what that did was remove the quantity of basically the combinations of types of inlets from 5 to 2, because it used to be you had either one side of the wall or both sides of the wall, and then with all the combinations of all the throats, there was 5 types. Now there's only 2. It's either type 1 is one inlet on one side of the barrier, type 2 is inlet on both sides of the barrier. So that's gotten a lot more simple. And the one other thing I wanted to point out, because I've seen several designers had sent me drawings where they were trying to make grade separated work with the single-sided inlet, where you can see that the actual wall of the inlet supports the barrier. So this is not designed for grade separation. Typically, when you need grade separation, you have to be using the double-sided, and that's all that really accommodates that. That was stated in the previous standard and the centerline note, but we just went ahead and made that a lot more clear. The single box is for symmetrical only. Okay, moving on to shoulder barrier inlet. So this one's pretty quick. We just switched things to single slope. We clarified the usage. And I guess the major change is just changing the name of this index sheet. So it used to be called barrier wall inlet, which is very similar to the 3 other types of inlets that work with barriers. And so the usage really wasn't clearly distinguished with the index title, but now we've made an effort to do that. So in index 521001, as we've seen, there's the median barrier, shoulder barrier, curb and gutter barrier. And so this one works with the shoulder barrier. So we just wanted to go ahead and make that clear, and then we call out exactly what index it works with. And that's basically the only change there. And then moving on finally to the third type of barrier in 521001 is the curb and gutter barrier inlet. And so we've clarified these details significantly. These are completely redrawn. They look a little bit clearer now, easier to follow. You can see that, you know, the heel here, this all corresponds exactly to the curb and gutter barrier in 521001. They work together and align the same. And again, we removed that upstream throat. It was kind of the indentation underneath the barrier. That's gone now just for simplicity. And then the final significant change here was that the previous standard had an 18-inch drainage slot. It was kind of at the most narrow and vital point of the barrier right here over the inlet. And that was basically going right through where reinforcing should be and things like that. And so to make a more robust structure that's, you know, has improved constructability, less interference with the rebar, we've switched that over to 3.5-inch PVC pipes. The designer can call those out at sag points and curves. Otherwise, as a note for contractors to place them in at the low points. And basically, that's for draining the sidewalk into the inlet. And so we now are using the PVC pipes, and that also was approved by the state drainage engineer. And then last but not least, single slope barriers, how that affects the aluminum lighting standards. So you can see we updated a single slope throughout. Now, because for medium barriers, we have continuous reinforcing, we've also had to change this segment that supports the lighting foundation to also have continuous steel so that it corresponds to the medium barrier, which also has continuous steel. And then the one thing I like to keep bringing up, because I have seen this in some projects in the past, the difference between the traffic railing, which goes on a bridge. We've recently made this distinction more clear, but the traffic railing typically is the item that goes on a bridge. The concrete barrier is what goes on a roadside that's supported by soil. So there's a difference there. Difference shows up here, where this is concrete barrier supported by soil. The conduit runs underground next to it. And so we have seen plans that had conduit running in the barrier, and that caused all kinds of issues, and it's not a standard, so I just want to point that out. Conduit goes underground. Again, this is a different type of foundation, similar thing. Switch to single slope, spread the reinforcing out a little bit. Conduit is underground because it's a barrier on soil. And then finally, this one is for traffic railing for mounting on a bridge deck. And so switched to single slope. Just want to point out that this one has the conduit inside the traffic railing because it's on a bridge. There's no place else for it. It's sitting on a bridge deck. And so with that, we've made it through all the indexes I wanted to explain today. And you can go ahead and see if there's any questions. We might be able to push those to the end. Okay, it sounds like you've been addressing the questions. And so with that, I'll pass this on to the next presenter.
All right, thanks, Richard. At this time, we will be moving to Ed Cashman's portion of the presentation.
My name is Ed Cashman. I'm a standard plans engineer with the standard plans section, and I will be discussing some of the standard plans that I have updated in this cycle. Now, as a disclaimer, this is just covering the significant changes, and for the totality of the revisions, you're going to want to see the revision log. So starting with index 102-100, this was previously index 415. It is now called temporary barrier. This index is generic to multiple types of temporary barrier systems. Previously, this covered primarily concrete, but with the changes that we have now made, this index is covering concrete barrier, steel barrier, and water-filled barrier. Now, the primary differentiation between these barriers is whether they are freestanding or anchored. The other major change in this index is that deflection space is now setback distance. The table has been updated, it's simplified. It was previously very cumbersome. And when you look here, you'll see that anchored and freestanding are now the two conditions for how to choose the setback distance, the lateral offset. Now, in the previous version of the standard design standards, the minimum setback distance with the type K anchored was 1 foot. It is now 2 feet, and this is primarily because as a result of MASH, the setback distance was actually higher than that 1 foot, and we consider the 2 foot to be a reasonable update. Now, 102-100 previously had a couple of sheets dedicated to the length of need calculations. Those have been removed, and you are going to want to see the standard plan instructions for length of need. Crash cushion details have been moved from here into 102-110, and see the APL for any proprietary barriers and their requirements for how to connect to crash cushions. Moving on to 102-110, this was previously index 414. This is type K temporary concrete barrier. There are a considerable number of revisions that occurred in this index, but most of them are fairly minor, and they're for clarity with the new temporary barrier, the changes that we made into the 102-100. As part of that effort, some of the information that was previously shown, like the setback distance, that's now just a reference to 102-100. The fabrication details that were on sheets 1 through 3 of 15 are now shown on sheets 15 through 17 of 17. Probably the most significant change here is that the 3321 anchorage transition detail has been added on sheet 1, and that's shown here below. Index 102-600, we revised the preference to general notes, and the information contained therein was revised. So you can see here we have the preface with the manual on uniform traffic control devices, and that has been simplified. The temporary substitution of RPMs for paint or removable tape detail has been removed from sheet 12 of 12. That's because this, according to the MUTCD, there was supposed to be an engineering study involved in the placement of this. It's typically not supposed to be used on the outside lane lines. So we don't really want this to be a frontline option, and we're not saying that it's not allowed, but it needs more thought if it's going to be used. Index 102-606, this was previously Index 606, two-lane, two-way, work within the travelway signal control. The general notes have been revised, and we added another option for having a half-mile closure. So you can see here what notes have been eliminated. And this is what the general notes look like now. The reverse curve and keep right signs have been removed from all sheets. These signs are not necessary according to the MUTCD, and we do not use similar signs in 102-603, which is the two-lane, two-way, work within the travelway flagger control. Index 102-660, previously Index 660, pedestrian control for the closure of sidewalks. The general notes have been revised, with probably the most significant one being Note 6, which has been removed. And this type of information should be included in the TCP, and we don't want something in the TCP to overwrite necessarily what's in the standard plan. So it made sense just to remove that conflict. Now the sidewalk diversion has been revised. This previously showed a diversion into the travelway, but this isn't typically feasible, and a more realistic option is that a temporary sidewalk or walkway would be placed within the TCP. Index 546-010, previously Index 518. This is ground in rumble strips. The half plan that was showing the shoulder ground in rumble strip placement has been removed and placed into FDM 211.4.4. This is something that should be detailed into the roadway plans. It's not something that should just be relying simply on the standard plan. And this also corresponds to what we're going to be doing with the ground in rumble strips on arterials and collectors. For the time being, the details are also described in the general notes of this index. Additionally, the concrete pavement details that were on sheet 2 of 2 have been removed. The rigid pavement with the flexible pavement shoulder detail has been incorporated into detail A of the standard plans as a note, and the profiled thermoplastic criteria has been moved into FDM 211.4.4.2, as with the typical placement of the rumble strips. This is something that should be detailed in the plans for the profile thermoplastic. So, and there's no real additional criteria as far as how to place them. It's more or less if you're going to use it in lieu of rumble strips. So this sheet was eliminated, and this is showing what's in detail A of the standard plan. And this 24-inch for the rigid pavement with flexible pavement shoulder covers what was previously shown on sheet 2 of 2. Index 665-001, previously index 17784, pedestrian detector assembly installation details. The entire index has been reconfigured, revised, but in general, the content is the same. Now, sheet 2 of 2 has been removed. This was showing some sign details, push button location details. For the sign details, that's covered by the MUTCD, and these sign details shown in the standard plans were just a duplication of that. It would be preferable that if you're going to use the signs, please see the MUTCD. The location details at the bottom left aren't necessarily what we're looking for as far as the placement of these push buttons. For that, I would say to see the MUTCD as well. Index 700-010, previously index 11860, single column ground signs. The concrete stub detail has been removed and the driven post detail has been revised. These are both on sheet 5 of 9. And this is showing the new driven post detail in the standard plan. You can see that the soil plate has a different configuration from what existed previously. And this is due to maintenance issues. The concrete stub was having problems with the concrete cracking. The driven post, this is easier to insert into the soil if you're trying to replace an existing driven post. Index 700-020, multi-column ground sign. We deleted the 8-foot requirement off of the detail on sheet 1 of 3. And this is because there is now an additional 7-foot requirement for the length of the post from the base connection to the bottom of the sign panel. What has been occurring previously is that some of those posts were getting very short, especially on significant back slopes or fore slopes, and that was impacting the ability of the sign to actually break away. So this is something to keep in mind when you're designing your multi-column ground signs, just to ensure that those posts are at least 7 feet from the base connection to the sign panel. Index 700-101, previously index 17302. Typical sections for placement of single and multi-column ground signs. There are index-wide changes for consistency, but most of these changes are fairly minor. The wrong way sign criteria was pulled out of the case 2 detail, and a specific detail has been created for these wrong way signs as case 10. So this is showing the previous case 2 where the wrong way sign was just an asterisk of the typical sign placement on rural roads and actually strictly on expressway ramps in this case. So the new detail is just showing the specific use of the wrong way signs. This was the old design standard was in some occasions causing some confusion. Index 706-001, previously Index 17352, typical placement of raised pavement markers. Once again, there are index-wide changes, but most of these are relatively minor. 2 new sheets have been created for optional RPM details at median openings, islands, and traffic separators. If these details are used, they should be called for in the plans. And this is detailed in the standard plans instructions as well as far as how to call these out. This is showing the new optional RPM details for RPM placement at median openings. And this is the RPM placement at islands and traffic separators. Index 711-001, previously Index 17346, pavement markings. There are index-wide changes for consistency, but again, most of these are relatively minor. 2 new sheets have been added to clearly show longitudinal markings. So this is showing how to place the lines longitudinally, what the distance is from the edge, how they relate to joint lines. And this section sheet here is showing for buffered bike lanes and also additionally the express lane striping. Some details have been removed from this index. These include typical crosswalk markings for curb ramps on the old sheet 6 of 17. This is a duplication of what is shown in the curb ramp standard plan. The restricted left turn lane marking on sheet 7 of 17, the old sheet 7 of 17, has been removed as well. These are not necessarily reflecting our current practice for how we design roadways, and there is very limited information as far as how these are different from what we typically do. That is true for this typical intersection 2 through lanes plus left turn lane with crosswalk. That has been moved as well. The stop bars, crosswalks, and double center line details on the old sheet 7 of 17 has been consolidated. Now this is more or less a duplication of what was shown previously, so it has been removed. The one-way signs on divided highway intersections detail has been removed and placed in FDM 230 as an exhibit. This is because these signs should be included in the signing and pavement marking plans. This is primarily designer information. The contractor will understand how to place these signs from the signing and pavement marking plans. This is the same case with the mid-block crossing details that were on the old sheet 13 of 17. This has also been placed in the FDM 230 as an exhibit. The signing details for schemes for transition 2-lane to 4-lane roadway on the old sheet 9 of 17 have been removed from that detail and placed in FDM 230 as an exhibit. Similarly to the previous details, these signs should be included in the signing and pavement marking plans, and it's not necessary to show them here. This is just designer information. The sheet with the exit number details, the old sheet 10 of 17, has been removed and placed into index 711-003, the interchange markings index. And that is because these details are only relevant to those interchange markings anyways. Now, the minimum parking restrictions for non-signalized and signalized intersections on the old sheet 15 of 17 have been removed. Those are now covered by FDM 212.11.5, and that's a section for on-street parking at intersections. This is primarily designer information. Two sheets with profile thermoplastic details, the old sheets 16 and 17 of 17, have been removed. And this is part of the effort to combine with rumble strips as far as how to place these audible and vibratory treatments. See FDM figure 210.4.4 for the criteria on where to place these audible and vibratory treatments. A new sheet has been added, with the markings for school zone details. This is now sheet 14. Index 711-002, previously index 17347, bicycle markings. The sheet with the shared lane markings details, previously sheet 2 of 5, has been removed. See the FDM 223.3 for guidance on the shared lane markings. Additionally, the sheets dealing with the bike lane typical layouts, previously sheets 4 and 5, have been removed, and those are now exhibits in FDM 223. This is similarly to the signing details. This is designer information, and the plans should be detailing how to place these pavement markings. Index 711-003, previously index 17345, interchange markings. There are index-wide changes for consistency, but most of these changes are relatively minor. One of the more significant changes is that the chevron spacing chart on sheet 1 of 1 has been revised. All chevron spacing is now 60 feet. A new sheet has been added with an interchange intersection. This is now sheet 6 of 7. This is showing, in addition to some of the other pavement markings, how to place the wrong way arrows at intersections of interchanges. The wrong way arrows should not be placed in between consecutive directional arrows. The sheet with the exit number details is now sheet 7 of 7 in the interchange markings. This is more or less intact from the pavement markings index. And that is the end. If you have any questions, my contact information is here on the screen.
Good morning. This is Steve Nolan. I have the pleasure of closing out the presentations today. So we'll get started. There's about 30 slides in this presentation, and then some of it will reiterate what Durwood mentioned in the beginning, just for those that have turned in late. So I'm going to go over some of the global changes related to numbers and titles specifically for the structure standards. We'll talk about what Brexit is, some of the discontinued standards, and minor and major revisions to the standard plans, the instructions, and data tables. And then we'll finish up with some work on developmental standards and what we're planning in the year ahead. So we affectionately term the movement of the structures plans, standard plans to the contract plans as Brexit, bridge exit. And it just makes it easier to talk about it quickly rather than standard plans to structures plans. And with all the other changes to the naming conventions, it's a convenient acronym. So why are we doing this? Well, traditionally, the standard plans were included with the bridge drawings, and then we merged structures and roadway standards around 2006 and went to an electronic book. Those were just included in the contract plans via reference. This didn't meet everyone's needs, and so in an effort to provide the maintenance office a better set of preservation records that need to be maintained for the life of the bridge, we've decided to move the standard drawings back in with the contract plan set for the bridge components. That should also make it a little more convenient for the contractor, having all the drawings at his fingertips in the same package. And the designers of future rehabilitation, widenings, etc., will have all the information available without necessarily having to search and interpret the correct year that the bridge was built. So how are we going to do this and still be true to the one DOT principle and not completely segregate from the road and traffic standards? So we struggle with that, but we're keeping them all in the same standard plans. As Durwood mentioned earlier, we've just split the naming convention into two subsets of road and bridge. What that means, looking at the old list of standards, basically the old 2000 series all moved to the bridge standards plans, and then the traffic railings that were mounted on bridge structures were also moved. There was also box culverts that some are classified as bridge structures, some are not, so that had to be handled separately as a special case. This is a screenshot of the standard plans webpage with the lower portion devoted to the standard plans for bridge construction. You can still view the drawings that for those relevant index numbers on the web page. They're just not contractually binding. So I draw your attention to the highlighted note at just below the banner, which advises that these drawings are for information only, and the contractor is required to use those drawings in the contract plan set for construction. So as you know, that's not all. We've got name changes and number changes. So there was a triple whammy this year for you all, but I'm sure you can handle it. We've got an example here of what that means, moving the structured standard plans into a contract set of plans for bridges. So this would be the case where you had a generic or overview cover sheet without the full index, and then there would be a separate index of sheets. And we are putting these standard plans for bridge construction directly behind each bridge number. So those relevant standards for each bridge are included in a single PDF file, but the names of each of the individual standards, applicable standards, are included in the index. I refer you to the Structures Design Bulletin 17-09, which has more examples on this and some explanation. We also have a delivery tool that helps assemble these drawings for the contract package. The Excel file that is the crosswalk between the pay items entered into the transport or designer interface, utilizes the pay items and then highlights specific indexes that may be applicable to the project. It's always up to the designer to verify with a checkbox whether to include that particular index in the PDF package for the contract plans. But we've done all the searching for you, and you should know what's required in your set of bridge plans. This application also develops a text file that can be placed into the index automatically. So that is all available for you. It's delivered as a application in the CAD load, and you would find it in the structures bar menu under applications, shown lower on the screen there. Just out of interest for those that want to see how this fits into the sheet ordering sequence from the CAD manual, we have a sheet order for the DGNs and the PDF. Please note that we're not including DGNs in the electronic files for these contract plans for the standards, just the PDFs. And you can manually do this directly downloading from the website, but this just expedites the process. If for some reason you don't have the latest CAD load, you can always get a copy of Standard Plans package or program off our support page on the Structures Design website. Link provided at the top of the screen there. And one final thing is a little clarification on the quantities issues related to box culverts in particular, since we have both bridge size box culverts and non-bridge size box culverts. So the standard plans for the box culverts still have to be included in a structures component, but since there is sometimes no bridge number associated with the box culvert, it needs to be, within the summary of pay items, it will be listed under a roadway item for quantities, and therefore the summary of quantities in the plans must be in the associated roadway component set of plans. If it has a bridge number, then it will automatically be loaded into that particular bridge number with all the other bridge items, and so those quantities would then be summarized in the standard bridge summary of quantities table. So there was some changes to the FDM to identify the particular issues about box culverts. So there's more information out there, and there'll be a follow-up bulletin shortly with some additional information, but the procedure's already established out there. This is not really any different from how we handle retaining walls, in that the details are included in the structures plans component, but the quantities are listed under the roadways section, and then the summary of quantities is included in the tables in the roadway component. So that's it for the overview on Brexit. If you got any questions that aren't handled in the provided documentation, then feel free to send me an email and we'll try and point you in the right direction. All right, so moving on specifically to the standard plans themselves, as you know, the numbers change. The format of the numbering is based on the specification number or the main specification that pertains to the index, and then the remaining 3 digits are a unique identifier. We have tried, at least structures, to keep something similar to what we had before, just to make it easier during the transition. That wasn't always possible or necessarily logical for a long term, but for the most part, we were able to do that with the structured standard plans. It was not as easy to do that with the roadway. So on this screen, we're showing some common changes that occurred with the first set, the bullet railing and concrete parapet. They used to be all grouped together under the 800 series. Because of the components are covered by different specification sections, they actually get split up now into 521 and 515. But if you look at the purple numbering, that's similar, not always identical to what it was before. So that's a crutch to help you through the transition. Composite bearing pads, that was a bit of an outlier since there was no specific construction specification. There is a material specification, but the pay item is actually under the 400 series. So that one we kept with the 400 series for concrete work. Walls, they used to be grouped under the 6000 series, which all seemed logical and great, but since those components are all either cast in place concrete under 400 or pre-stressed under 455 or even MSE walls under 548, they all get segregated. Those are not bridge standards, so they're actually in the standard plans for road construction. So that's another thing you have to be aware of when you're hunting for a particular standard, that you're in the right group. And then finally, there some of the pre-stressed elements as we begin developing composite reinforced products, or FRP, fiber reinforced polymer. We have 2 standards right now for the bearing piles for bridges and the sheet piles that contain both carbon pre-stressing and stainless steel that were previously separated under a 22,000 series to keep those all together. Well, once again, to be consistent with the specification governing those indexes, those are now grouped together under 455, and the separation is achieved by the unique numbering series at the end. So piles, the FRP piles are under the 455-100 series, and then sheet piles, that one was up in the air. We couldn't go up to the next 100 series, so we kept the 440, which was the 22-440 was the previous numbering. There are also a number of minor changes to the names of individual indexes. Might be frustrating to you all, but when you see them listed out on the table of contents, it makes a little more sense of why we did that. Basically, the main topic of the index is the lead part of the name, and then the subcategory for the particular details that might be shown on that index number are secondary. So when you're scanning through, you'll see in this example, forward I-beam will be there for both the general details, individual different beam heights, for the build-up tables. So just something to be aware of. And then similar sort of situation with the precast sheet piles and some others where we've got the same lead name, and then the selective material type is appended to the end. So just more changes. Revision logs are always there to see what changed under each individual index. I would mention that earlier, so we won't dwell on that. So moving on to what was deleted or retired, the F-shape changes that Richard went over in detail obviously have been replaced with a single slope. So there were 3 index numbers that were deleted because of that, and then because of the MASH, the MASH TL4 requirement, the corral railing was also retired since it did not meet the minimum height that we needed for TL4. We may look for a replacement for that. There's obviously a lot of work being done at the national level to get all the states up to speed on MASH, so stay tuned there. There are also some other changes to various indexes because of the changing shape of the traffic railing. 3 of those are listed there. And if you refer to the 2017 design update training, Charles Boyd and I did it at the Expo, there's some more information on transition from the F shape to the single slope and the background on that. So some of the minor changes we'll go through quickly are listed there. Consistent naming conventions with the specifications, the generic naming of traffic railings that Richard mentioned earlier, where those basically the traffic railings that are located on the bridge remain traffic railings consistent with the AASHTO bridge design specification, and then those that are wall or shoulder mounted, which might be considered more roadway-based railings, named concrete barriers. Maybe one day AASHTO on a national level will get consistent with that naming convention, but that's where we're at right now. There are also changes to some of the other noise wall or traffic related design standards because of that nomenclature. So examples are listed there at the bottom of the screen. Moving on to some specific detail changes within the indexes, because of the change from 32-inch to 36-inch height in the traffic railings, the height of pedestrian railing posts to maintain a consistent 42 or 48-inch total height resulted in detail changes to the posts. We also added some type designation changes to make that clear and separate it from previous year's versions for the fabricators. We've used dual dimensions on those drawings just to keep the number of sheets down. So I invite you to take a look at those 2 indexes. Then for the traffic railings on bridges, we removed the delineator spacing table, which the spacings will be included in the specification. I have a question mark there next to section 705 because it's not in the current spec, but I presume it will be in there in July when these become effective. So don't send me an email on that one. The height transition between roadway and bridge to accommodate the 2-inch the future asphalt overlay results in some transition details from 36 to 38-inch height. And then we've also made some changes to accommodate 3 rows of conduit in the traffic railings. And as part of that, we modified the previous anchorage reinforcement that was issued for the single slope on bridges to open up the core of that traffic railing to better accommodate the traffic railing, the conduit. So those are actual changes to the single slope that had been previously issued under the developmental and under last year's design standards. The last one here was the 27-inch concrete parapet. As mentioned earlier, the type of those posts supporting the bullet rails may have changed depending on which index you're looking at. Moving on to noise walls, there were some minor changes to the spacing of the stirrups, the request of the contractor, the precasters rather, and then we also clarified some acceptance criteria for those posts for basically the 22-foot high posts in the highest wind zone, where the cover on the backside of the post was getting a little tight with the number 11 bars, so we've relaxed some criteria there for acceptance in construction. For the perimeter walls, similar change to the post, and then for the bridge fencing, we add some bracing details to one of the types to support those posts and expansion joints. There's also quite a few changes to those drawings because of the F-shape to 36-inch single slope change. So take a look at those and be aware of those subtle changes. And then one new standard that we have is the bridge fencing over railroad, which is basically a curved top fence, similar to what used to be under Index 811. But instead of being on the back of the sidewalk, it is on the back of the traffic railing. It's slightly higher, and some of the horizontal, all of the horizontal rail members have been removed for crashworthiness. So that was issued as a developmental index on some projects under 813 series. So it comes in at 550-013. This is only to be used when required by the railroad permitting authority, and if there is no sidewalk, such as a limited access facility, then this is probably going to be your only option to get that permit through. For the traffic railing noise wall, 8-foot bridge mounted, and for the roadside mounted, there has been modifications to the bottom portion of the structure to accommodate or match the shape of the approaching traffic railing. So that is now a single slope shape on the bottom. The reinforcing was tweaked a little bit to open up the core of the railing to accommodate conduit, which was a problem in the previous standard. And so once again, 3 conduits are allowed to be included in those elements. Similar changes to the shoulder-mounted, footing-supported traffic railing noise walls. The difference here, well, the minor difference here is the name change. Traffic railing got swapped out for concrete barrier because it's not on bridge. So, but since these aren't on bridges, the PDFs don't need to be included in the structures component set of plans. Moving on to more traffic-related changes, the transition to guardrail has been tweaked slightly. Previously, we had a 4-inch cutback. It's now 3 inches to be consistent with the roadway traffic railing details. The transition to 38-inch height, which I mentioned previously, is detailed on Index 521-427 and 428, the single slopes. And then the embedded the conduits, there's a slight name change to the index, and then detail changes related to the shape of the traffic railing, and then accommodating the 3 conduits in those elements also. Another change with that is now conduits are specifically paid for. They're not incidental to construction. So those have to be quantified and summarized in the quantities. In addition, the junction boxes are also required to be quantified and have a separate payment item under the 635 series. Details are included in the instructions on what is required for those. So I encourage you to go and read up on the SPI. Here, this is the slide talking about the new pay item number. There are also some other changes to the instructions related to traffic railing shapes. This is a little subtle, but some of the box culverts, because they're not bridge structures, they're not directly referred to the bridge standard plans. So details are being added into the box culvert index, and the data table for the box culverts has been updated to include a bar bending detail for the anchorage reinforcement. And because the supporting parapet is variable height depending on the amount of fill above the culvert to the railway surface, the designer is required to put a dimension in there so that the contractor has the correct dimensions for the bar bending. So you refer to the SPI for index 400-289. There are details provided in that. And then for the approach slabs, there were some minor clarifications to the optional base and what to do with the quantities for that element. As far as the data tables, which are included in the structure cell library, the one significant change has been the addition of a new column to the build-up and deflection tables for the I-beams and the U-beams to note the expected net beam camber at release. This gives the producer a benchmark to monitor during the camber growth of the beams. So that was included at the request of our materials office and the producers. Designers are required to include that information, which they already have calculated during the design phase. The data tables have all been updated, obviously, to match the new naming and numbering conventions. So those are included in the latest CAD load. They can also be downloaded separately from our structures standard support page, and the highlighted file is identified there at the bottom of the screen for the latest CAD load. There will be a hotfix coming out. There are some minor changes that need to be included. It escapes me exactly what those are right now, but so there'll be a hotfix coming out by the end of the year to include some of those improvements that didn't quite make it into the last CAD release, which came out in October, just before the standards in November. Looking ahead, in our crystal ball, we have one index that we've been working on for a while now, the precast intermediate bent caps, part of our accelerated bridge construction initiative. That will be released early next year. If you have an interest in that, contact me and we can provide you some more details. The 300 series off system superstructure packages that were released, we still have the 600, the 60-foot span length to add, which was in the original plans. So that hopefully will be out by mid-year. And then in June, there'll obviously be some updated information at the Florida Innovative Transportation Symposium, which is the new Design Expo. So look forward to seeing many of you there. And just a final message from our office and our group that we're always willing to consider your suggestions, and all we do is encourage you to fully read all the documentation provided before in the structures plans instructions. All right, that's all I have, so thank you very much.
All right, thank you, Steve. With that will conclude this training for the standard plans. Again, if I forgot to mention it at the beginning, all of these different segments will have been recorded and will be posted on the training website for future viewing. There's been a number of questions come through on the question dialog box on the go-to, and we've been answering those questions as we went along. We can post those in a Q&A as well. If you have any additional questions that you might come up with, again, like Steve mentioned, all of our contact information is located both on the website and in this presentation, and we always invite any questions you may have. Please bring them to us. With that, have a good day and take care.